Morning. This is the presentation of the major project for SEMM 1513, Introduction to Design. We are representing Group 2 and we are working on the design of a bottle upright positioning system. The system will be a part of the production line for 500 ml Desa mineral water bottle. In this video, we are going to present our individual concepts, evaluation metrics, modified sketches, proof matrix, and sketches and CAD model for the final concept.
This is also Frank Shelton, and these are my individual sketches for my concept of local upright positioning system. This is the full assembly, which shows the 4 separate major mechanisms for the system. The first is the hooking system. This is to orient the bottles in the same direction. The next system is a floating roller to maintain the horizontal position of the bottles. The third system is side gripping conveyor system. It is to orient the bottles in an upright position. The final mechanism is railing to prevent the bottles from falling off the conveyor belt. The explorative sketch shows the explored views of different components of the mechanisms. For the first mechanism, hooking system, we have a hook which attaches to the hook breast with main bolt, and it is fastened with a spring. For the second mechanism of the system, we have a floating roller. The floating roller has 2 mounting plates, and the roller is attached to the both of them, and a motor is mounted to a motor mounting which operates the roller. For the third mechanism, we have side gripping conveyor system. It consists of conveyor belts, rollers, a motor to operate the conveyor. It is attached to a motor mount, and there is a ram. The explanatory sketch shows the operations of different mechanisms in the system. For the first mechanism, the hook of the system attaches to the mouth of the bottles, which are facing the direction towards the movement of the conveyor, and flips them in the opposite direction. The bottles that are initially facing the opposite direction does not get hooked and thus bypasses the process. In the second step, the roller tips the bottle to maintain their horizontal positions. If the bottles are not in a horizontal position after the first system, the bottles passes under the roller. The third mechanism, the side gripping conveyors. The side conveyor belts grips the base of the bottles after the bottle hits the floating ramp and orients them in an upright position. The side conveyors will then carry the bottles and deliver them to the main conveyor belt. The main conveyor belt has railings throughout its length to prevent the bottles from toppling of the main conveyor belt while delivering them to the next system. This has been my overview of my individual sketches for my concept.
Hi, my name is Romano Lakin. I'm from the second group, and these are my individual sketches. So for the first part, I will explain about the food assembly. My part consists of 4 components, and the first one named hooking system. The second one is fixed gate. The third one is drop down tunnel, and the final component is side conveyors. All these parts are going to work each other to make our upright positioning system works. And then this is my second sketches. This second sketch will explain how the components are combined. This is called explorative sketch. For the first part, the hooking system, it consists of 2 parts, body and hook. For the body part, it will made from plastic, and the hook also the plastic, so we can cut some cost in here. For the second part is fixed gate. Fixed gate, only this kind of thing made from plastic, we can do it from 3D printing. And then for the third components, which is drop down tunnel. Drop down tunnel consists of many rollers, because this is also small conveyor in there. So the belt will make from rubber, and then the roller itself will make from metal, and the screw is from steel. You can just find this in the DIY store or any furniture shops. And then for the last part, which is also consists of roller, because it is called side conveyors. So there are rollers in the body. The body made from plastic, and all the rollers will make the component works. Okay. For my third sketch, it is about explanatory sketch. It will explain how the component works. For the first part, it is called hooking system. It will make the bottle from any position so that it will facing the bottom part of the bottle when going forward. Because when the bottleneck is facing forward, and then this hook will turn the bottle 90 degree, and then it will fall like this so that the bottom of the bottle will facing the conveyor belt. And then the second one is fixed gate. Fixed gate is to make sure the bottles are not tilted and make sure it is in a solid position like this. So to make sure that this fixed gate will make the bottle enter to that state, and then make sure the bottle is firmly straight like that. And then the drop down tunnel is about the conveyor and the belt. So the bottle will go up, and then from the conveyor it will move the bottle from here to here, and then by the gravity the bottle will fall itself. It will make the bottle stand like this, stand upright. So this part are the most important part for me, for my working system, because it will make sure that the bottle is standing like this. And then for the last part, to make sure the bottles are safely transferred to the other system, we make the side conveyor. Side conveyor will make the bottle stand firmly so that it will not wobble. That will cause the bottle fall. So that's all for my parts. Thank you.
I'm Rose Carolina Gomez, and these are the sketches from my individual concept. First, from the full assembly, I have 4 different mechanisms for the 4 functions of our system. The first mechanism is the robotic arm that aligns the bottles in the same direction. Next is the floating roller that maintains the horizontal position of the bottles. Third mechanism is the side gripping conveyor belts that will make the bottles stand up in the upright position. And then lastly, the side conveyors will carry and drop the bottles on the main conveyor. Moving on, this is the explorative sketch where the major components of the mechanisms are shown. The main conveyor belt consists of a frame, a roller, and a base. The first mechanism, that is a robotic arm, has a frame, an arm to it, and a gripper. The next mechanism, that is a floating roller, has a mounting plate and a roller. And lastly, the side gripping conveyors has a mounted motor to it, and the frame, and finally the conveyor belt. The explanatory sketch explains how each mechanism works. When the bottles are being delivered randomly on the main conveyor belt, the robotic arm picks up the bottle mouths and orients them in the same direction, that is, opposite to the conveyor movement. In the second step, I have floating roller. So after the first step, the bottles are supposed to be in a horizontal position. If some bottles are still vertically placed after the first step, these will be pushed down under the floating roller to maintain the horizontal position. Then in the third step, the side gripping conveyors will grip the bottle at the base and put it in the upright position. And for the last mechanism, the side conveyors that are placed at an angle from narrower to wider carry the upright position bottles and drop them on the main conveyor. This sums up my individual concept for the bottle upright positioning system. Thank you.
Hello, my name is Anwar Hakimi, and this is my individual sketches. Okay, for the first part, this is full assembly. As you can see, my full assembly is consisted of, first part is robotic arm, vertical side roller, move on to revolver, and at the end is side conveyor. This part is explorative sketches. As we can see here, all of the section that I said before is been is being deduced by all of the parts. Like this one robotic arm is consist of a rectangular big base, the arm, and the part where it will grip the bottle, which is the gripper. This one is our vertical set roller. This consists of this the motor, the bracket, some screws, and roller. This one need to be shown perfectly because it consists of many components. And then we go to the revolver, which is have only two parts, which are bracket and the body. It's only a circular body. And then we move on to the last part, which is the side conveyor. This side conveyor is pretty complicated because it consists some modified thing that I do, which is a semi-circle shape, which are consist of roller, conveyor belt, some screws, bracket, and motor. That's it for the explorative sketches. And these are my explanatory sketches. This is where I will explain to you how each section will be working. Okay, for this part, for the robotic arm, the gripper part of the robotic arm will hold the water bottle with which the part is in a forward position. Then the gripper will flip the water bottle to make the bottom face the forward position. Also, if the position of the water bottle is already in its right position, it will not trigger the mechanism. And then we move to the second part, which is the vertical set roller. The vertical set roller ensures any wiggly movement of the water bottle is eliminated and is in a still position, which is will not move at all. We proceed to the revolver. When the water bottle will go into the hole in the circular body of the revolver, then it will make the water bottle in a standing position. Take note, some will fall or some will not. That's why at the last part, which is the side conveyor, the side conveyor is the section which is the water bottle will be safely transferred to the next group. It also will correct mistake made by the previous section when the water bottle is not in the stand-up position. That's it from me. Thank you.
Assalamualaikum. My name is Muhammad Manur Rakib and this is my individual sketch. Okay. For the firstly, I have sketched the full assembly sketches. And the first component that I have drawn is hooking system. Next is vertical set rolls, followed by fixed gate, and lastly the rig. Okay, for the exploration sketch, for the first component that I have deployed is hooking system. Hooking system consists of two parts, which is body and hooker. Next is vertical side rollers. Vertical side rollers, they have 5 rollers, which is connected by 10 screws. And lastly, fixed gate. Fixed gate is like it will move. It's like path for the bottle. So there's a roller for along the roads. Okay. Lastly, the exploration sketch. Exploration sketch. Firstly, hooking system. Hooking system is the hook for this system will lift up the bottle that move its mouth part first to change its position, which is to the backward. Okay, next is vertical side rollers. Vertical side rollers, it will make the bottle stay still and not moving around or like jiggling around. Okay, the third part is drop down tunnel. Drop down tunnel is the bottle will drop down from the higher points so that the bottle will stand up straight and standing. Okay, and lastly, welding. Welding, which is, for all we know, is to maintain the position of the bottle after the standing up of the bottle. Alright, that's all for me. Thank you.
This is the evaluation matrix. The evaluation matrix has been done based on the individual design of each member. The major criteria we have chosen for this are performance carrying a weight of 5, cost efficiency and efficiency carrying a weight of 4, and finally simplicity, endurance and safety carrying a weight of 3 respectively. Performance was evaluated based on the 4 functions of our system, which are direction assignment, maintaining horizontal position, upright positioning, and product transporting. After judging all the concepts, the total score for Rose is 155, Ayman is 150, Lukmanul is 147, Aswad is 165, and Lukmanur is 150, making Aswad Farhan Shafin the winner for the evaluation and the datum for Pew Matrix.
Okay, right now we will jump into the modified version of my individual sketches. Okay, for you can see right here, they already, like the previous one, there's 4 sections. But right now, I'm only going to change about two part of the section, which is the robotic arm and the revolver. Okay, this I will explain one by one. Okay, for the robotic arm, you can see the robotic arm will change its base to a floating position, as the arm can cover more space of the conveyor belt. Hence, the detection of the water bottle by the arm is increased. That's why I put it into the floating position. For the vertical side roller, it's already the same. But I will further explain it. For the vertical side, also for the side conveyor, both are the same. The vertical side roller does not need to be improvised, as its productivity has been achieved to the maximum. Also the same for the side conveyor, our last section. The side conveyor does not need to be improvised, as its productivity has been achieved to the maximum. The second modified version is the revolver. The revolver has a new look as it turns into a semicircle shape. This change is required as the round shape is not conventional to put on a conveyor belt. Semicircle shape that has a landed base is more suitable for the job. That is for my modified version. Thank you.
Okay, this is my modification from the previous individual sketches. Okay, what I modify is firstly hooking system. Hooking system is I add a spring for more flexibility, because if there is no spring, it will like not return to its shapes. Okay. The second modification that I made is drop down tunnel. Okay, drop down tunnel. The modification that I made is I add a stopper or a grip to that part, so that the bottle did not slide down the inclined plane. Because if there is no grip, the bottle cannot go up the inclined plane. Okay. What I did not modify is vertical side rollers, because the function of vertical side rollers is to make the bottle stay still or not wiggle around. So I think the part is functional properly. So I did not modify it. And lastly, welding. Welding also the same for the vertical side rollers, which is it is for the bottle to stay still in a upright position. So it is also do the function properly. Okay, that's all for me.
modified sketch. For the first mechanism, I have altered the shape of the robotic arm gripper for a better grip. There is no change in the second mechanism, so the floating roller remains the same. For the third mechanism, for the side gripping conveyors, I have added a ramp to help elevating the bottles. There is no change afterwards.
Okay, so I'm going to explain about my modifications on the first part. Whereas the modifications only take one sketch because I can explain it all of the components. Okay, the first part is called hooking system, as you know. So what modifications that I have already put into the hooking system is I add the spring. It is for more stability because as the bottle flow into the conveyor belts, and then the hooking will go up like this. And then how the hook is going to go back to the initial position? It must use the gravity. However, that is not so reliable. So I have made some modification where I put the spring so that the spring can take back the hook into the first position, so that the other bottles can flow without any friction, resistance. Okay, so the second part, as I can see that when I move the bottle into the part, there are no modifications that I can make because the bottle will go into this part perfectly without any fault. And then the third components, it is called the drop down tunnel. The drop down tunnel has some modifications. One modification, I have added the stoppage. The stoppage will make the bottles not fall while going upwards into the conveyor belts. This will make the bottles will smoothly go into the conveyor belt and not slip downwards. So the bottle can go upwards and then fall by using the gravity safely. Okay, then the bottles are going to the final components. The final components also same as the second components, which has no change. Okay, so that's all from me. Thank you.
This is the Pew matrix. The Pew matrix have been done based on the modified sketches. The datum for the matrix is Oswald's individual concept. We've chosen the same criteria and weight as the evaluation matrix. After judging the modified sketches, the total score of Rose is 12, Ayman is 9, Lukmanul is 7, and Lukmanur is 6, making Rose Carolina Gomez the winner of the second evaluation. These are our final concept sketches for the bottle operator positioning system. The full assembly shows the mechanisms of the system. The first mechanism is the hooking system, which orients the balls in the same direction. The next mechanism is side-mounted roller, which maintains the horizontal position of the balls. The final mechanism is the side gripping conveyor system, which orients the bottles in the upright position. The explorative sketch presents the explored view of the mechanism. For the hooking system, we have a hook which attaches to the hook base and fastened by a spring. The hook base is attached to the mounting plate. For the side-mounted roller, we have a roller attached to the mounting plate, which is operated by a motor, which is also attached to the mounting plate using a motor mount. For the side gripping conveyor system, the frames of the conveyors are attached to the conveyor base. For the conveyor, we have the conveyor belt, 2 rollers, and 2 motors to operate both conveyors. And finally, the ramp of the system is attached to the main conveyor. Explanatory sketch explains the operations of the mechanism. In the beginning, if the bottle mounts are facing the directions of the conveyor movement, the hook of the system will be attached to the mouth and flip the bottles to the opposite direction. Otherwise, the bottle will not be hooked and will be bypassed, thus maintaining their initial direction opposite to the movement of the conveyor. For the next step, if the bottles are not in a horizontal position after the first step, the roller will tip the bottles to maintain their horizontal position. For the third step, the side gripping conveyor will grip the base of the bottles when they hit the ramp and put it in an upright position. The ramp along with the side conveyors will then deliver the bottles to the main conveyor. Finally, the main conveyor has railing throughout its length, which prevents the bottle from toppling off the conveyor belt. This sums up our final concept. Thank you.
The CAD model has been created using SolidWorks. This is the isometric view of the complete system consisting of hooking system, side-mounted roller, and side-gripping conveyor system. The hooking system consists of an aluminum hook, a spring which are attached to the hook base. This mechanism is mounted to the main conveyor system using a mounting plate. The second mechanism is similarly mounted to the main conveyor, comprised of a motorized soft touch plastic roller. The motor is attached to the mounting plate using a bracket. The side gripping conveyor has two framed side conveyor assemblies attached to a separate base. The ramp in the mechanism is attached to the main conveyor. The mechanism has two motors to operate the conveyors mounted using brackets. The width of the main conveyor belt is 10 cm for the 500 ml DESA mineral bottle, which has a diameter of 5 cm. The frames and the base of the conveyor belts are made out of mild steel. PVC belts and plastic rollers have been used for the conveyor system. The material assigned for the mounting plates and brackets are stainless steel.
Okay, with this, we have concluded our presentation for bottle upright positioning system for group 2. Okay, thank you for your kind attention and for listening to our presentations. Okay, thank you.
This is the prototype of bottle upright positioning system by Group 2. Here are some footage of the parts and construction. Next is the working procedure demonstration. This is the hooking system with the side-mounted roller. The mechanism orients the bottles in the same direction. Next is the side gripping conveyor mechanism that puts the bottle at an upright position with the help of the ramp. This is how our prototype works. Thank you for watching.